So here is the third lecture basically. So in previous lecture the problem I was stuck here. Okay. So I'll read the questions carefully before starting the problem. So the inverters are driven off a supply of 2 volt and their threshold points are at mid supply. At what point of time V naught goes to VDD? So in here I need a VDD voltage that is 2 volt. Okay. So before analysis the circuit, so uh, we just go through like um, when V in less than not V in less than like T less than 0 and T greater than 0, we analyze the circuit. Okay. So the same circuit I redraw here. So okay, what is the circuit? Okay. Uh, So here is my circuit. Let's redraw. Here is one capacitor, one inverter here. Here again one resistor and one capacitor here. Here again one inverter, and here my V out. And here I analyze the circuit T less than 0. So if my circuit is T less than 0, then it is R, this is C, this is R, this is C, and RC is time constant is 1. So input is for U of T. So basically unit step signal unit step signal is just like this. So this is my unit step signal, and this point is T equal to 0. So before T equal to less than 1, my uh, input is basically 0. So here whatever the input, that is basically 0. So if my 0 is here, then same like capacitor also be T is the less than 0. So in this point my voltage also 0. So if my input V in 0, then whatever the what's my output here? Here my outputs like the inverter swing is 2 to 0, I think. So 2 to 0, like if you go through inverter circuit, so it is just like I go through a CMOS inverter. So basically here is MOSFET. Here is your V in, like this 0 volt, and here your VDD supply. So VDD equal 2 volt, and you take the output from here. Okay. So basically this is the circuit. So if your V in equal to 0, so this will be on. If this will be on, then here your so, VD, like V out of this, like it's also be V out 1, you can say that. So it's 2, it's 2 volt. If it is 2 volt, then this point also like capacitor charge to 2 volt. So if 2 volt, here also 2 volt. If it is 2 volt, then here it is 0 volt. So this is my T less than 0. But what the requirement of we need a before starting T greater than 0, I remove this part. Okay, I hope you understood the CMOS inverter, like how it's work. That's the different part, but basically the just idea of how VDD goes to your V out of inverter. So again we redraw the circuit. Here my resistance, here my capacitor, and here is my inverter. Here is again resistor, again capacitor, and again inverter. So now I required my output, so it T greater than 0. So what is my output at T less than 0? So basically this part is 0. So if I and threshold VT was actually 2 volt, by 2, that is 1, is our v. So here I need 2 volt. So how we get 2 volt? So, and here is my capacitor actual charge, so it's not 2 volt. So if it is 2 volt, then how it is 2 volt? Because if it is high, so capacitor must be discharged. So how to discharge? So that's why capacitor should be discharged. So what is the here voltage should be? Here voltage should be 0 volt. Otherwise capacitor does not discharge. Like if suppose 2 volt, then how it is be discharged and it goes to like 0. So this is not possible. So this is 0. If it is 0, then how it is uh, 0? Like how it is 0? Like inverter, so at least 2, but 2 not required because vt, if my input supply is greater than 1, then my output should be 0. So here at least 1 volt, 1 volt is required. Okay, and here also just 1 volt, like below 1 volt, if my circuit is like here greater than 1 and here below 1. Okay, so that's the way circuit. And what is the supply here? Here supply is for u of t. So if my need 1 volt is here, so that is like 4 mm, u of t. So 4 into 1 minus e to the power minus t by tau. Tau means 1. So that is my 1 volt. So here t1 and another is 0 is here and 1 is here. So it's like 2 capacitor so discharging. So if I want to charge capacitor, so this is capacitor charging equation and this is capacitor discharging. Here capacitor would be discharged. Capacitor like should be discharged or must be discharged, so that my output should be 2 volt. So here 2 e to the power minus t by tau should be 1. 1 just equal 1 because after less than 1 volt it will be uh, shows a 2 volt output, and here greater than 1, so it's going to be 0 volt. So it's all in a series process. So 4 minus 4 e to the power minus t by tau equal to 4 minus 4 e to the power minus t by tau to 1. So if minus, then e to the power minus t by tau, that is 1 t1 equal to 1 by 4 or 3 minus 3 by 4. So it's 3 by 4. So my t1 equal to ln 4 by 3, and here my t2, this is t2, so ln 2. So my total time t1 plus t2, that is ln 8 by 3. So this is the time actually required. And if you don't understood how it comes, actually basically that our voltage equations of a charging like capacitor RC capacitor, then it's V infinite plus V naught minus V infinite into e to the minus t by tau. So from this V of t equal to, so V infinite means at the infinite what is the voltage? So that is 4 plus, and what is the voltage is here V naught. So V naught equal to V0 minus what is the voltage, that is capacitor store is 0 minus 4. So from here we get this. I hope you understood this. And discharging, for discharging the capacitor had like no infinite, that must be a 0. So your V infinite is 0, here V infinite is 0, and V naught equal to 2 volt. So that's why it's like this equation V naught equal to 2. So this, that's why here 2 e to the minus t equal to 1. I hope the concept is clear now. So total time is this, and here the answer. Here the answer. So the threshold voltage, how it's work, you can see here, and we need a 2 volt here. So RC equal to 1 second, that is the given in the question, and here the concept. I hope this video is now clear, like this concept. Sorry, video, I was saying the question. And here is another MSQ question. So basically, one inverter is here, and R and V naught is here, and C is here. Which of the statement is true? The circuit work as a stable. Okay, so basically it's a inverter, and the whatever the output is here, like suppose initially 0, it's 1, so my capacitor charge, and this is like 1 here, and it goes to 0 here, it goes to 0 here, then my capacitor like holds to 1, so it's is decreases like this way, and the 0 is here again, and if it is 0, then again this one goes to 0 and this 0, so it's a astral multiplier, and the circuit produce a predict square wave if RC value very low. Okay, the circuit produce a predict square wave of RC value is very low. RC value is low when like R is my fixed, but the also capacitor should be fixed. So if my capacitor fixed, so discharge rate is quick, like it is my capacitor discharge rate equal to whatever the voltage across the capacitor, that is I assume v naught e to the power minus t by tau. If my uh, tau is very less, so my overall this is very high, so if this is very high, so v to the e to the minus like something like 2 like 100, so it almost 0, it's 0, then 0 multiplied by 0, so overall 0. So that's why like the circuit produce a periodic square wave if RC value is low, and the circuit work as a bistable multiplier. No, this is not monostable multiplier. No. So option A and option D is correct. So representation of a Boolean function. So basic of number system decimal, like base 10. Base 10 is goes to 0 to 9, and how to represent 7 to 9. So this is my 7 to 9, that is 9 into 10 to the power 10, 10 to the 0 into 2 into 10 to the 1 plus 7 into 10 square. So if you sum this now like this way, that you got the 7 to 9. Okay, and the binary we already know that binary is only 2, base 2, so that is 0 and 1, so MSB the like most significant bit, and LSB less significant bit. So here 0 is the less significant bit, and also the left part is always MSB, and here is that number. So what is the we add, so 2 to the 2, that is 4, plus 2, that is 6, and 0 0 here, so this is 6, actually in decimal it is 6 base t. And example 101, 1 into 2 to the power 2, and okay, the like again how to write like from binary to decimal, so this is that's the way you can write MSB to the 0 to 2 to the power n minus 1, so two variable 0 1 2 3 decimal MSB. Okay, so this is the right way to you can write, and this is simple, not that much complicated. In here 3 variable in case 7, and 4 variable 15, so basically 2 to the power 4 means 16, and 16 minus 1 because it goes to 0, so total 16 number will be there, so it goes to 0 to 15. Same as 3, 2 to the power 3 equal to 8, so 8, so total 8 number will be there, so 0 to 7, maximum 7, 7 in decimal you can represent. So product of a literal, example a b a bar b a b bar a b c a b bar c a b c d, and a b bar c bar d. So this is the product of literals. and sum of literals a plus b, like this. Here you can see that there is no product term, so only sum. And min term and max term, so basically a logical AND operation including all variables where each variable can be itself or its complement. Then output of the minterm function is 1, and minterm is represented by small m, and 1 normal form, 0 complemented form. So 1 actually basically normal form and 0 complemented form. So minterm and max term. Here minterm it is a bar b bar, you can say. So if 0 then it's a bar, if 0 then it's b bar. Normally if 1 a position 1 then a, otherwise if 0 then a bar, in b position 1 then it's b, in 0 then it is b bar. Okay, so this is min term m0 m1 m2 m3. So this is the expression and this is my main term, and this is three variable a b c. For three will I already told that you goes to goes from 0 to 7, where 7 is the max decimal number you can represent by three variables, and here is the total like m0 to m7, and that's the way you can write. And example, f equal to w x y z, so it's a four variable uh, expression. And for min term like w bar x y z, so what is this? So basically here it is 1, so it is represent 2 to the power 2, that is here it is 2 to the power 0 represent. So here 0 means it's a 0 into 2 to the power 0, and here 1, so 1 into 2 to the power 1, and here position is 2, so 1 into 2 to the power 2, that is 4 plus 2 equal to 6. So this is my min term, that is m6. So n variable equal to 2 to the power n min terms. Okay, so here is the writing output digital system uh, using min term. So truth table for digital system is as follows. So here AB is my 0 0. If 0 0 then output 1, if 0 1 then 0 1 0 1, and 1 1 0. So find y. So how to find y? Okay, so my m naught plus m2 is my output, but how to represent in another way? So that's the we go through K-map. I think two input, so here is the two input. This is my A, this is my B. Okay, so in here 0 0 my output 1, so here 0 0 0 0 1 1. So 0 0 my output 1, and 1 0 a0 a1, so here 1 0. So it's basically nothing but my b bar. So answer is b bar. I hope everybody understood by this video. So repeat the same questions for the truth table also. So here is 0 and something a bar b bar c in b equation and this. So how to 0 3 4 7. So how to do this type of problem? Just K-map. Go through K-map. If you don't know K-map, so I will tell you. So just 0, write 0 1, and here 0 0 0 1. Here you think about 1 0, but it's not 1 0, because in K-map only one bit can be changed at once time. So here 0 1, so 0 0 2, here 1 I put. So here 1 will be there, and only one bit that is changed, that is this to 0 to 1. And now if I go through my 1 to 0, this one goes to 0, so only one bit change, and this one will be same, but this already you write, so this is unnecessary, so you should not write that way. So this is 1 0. Okay, and this is your A and this is BC. So 0 0 means here is 1 and this is your 3. So here is it 3 0 1 2 3. Here is 3 and 4. 4 is also here. 4 and 7. 7 is 4 5 6 7. 7 is here. Why it is 7? Because if you follow this A1, so select this all row, and 1 1, so select this row. So what is the common between this? So this is my uh, ABC. So this is this type of one. This is this. So this is my B bar, C bar plus BC. So this is BC. So this is B X not C. So that's my answer. Probably where is my answer? This is my uh, okay. This is another question, but basically y equal to this, but yeah, the like not minimize. So it can be minimizable, but maybe some other concept you want to teach, but it's okay. Here the like 3 0 2 3 4 6. So here 0 position 1, 3 position 1, 4 position 1, and 5 position and 6 position 1. Sorry, 4 5 6, 4 5 6. No, I think 0 1 2 3. Okay, maybe something is missing here. And sum of all min terms equal to 1. Okay, fine. Here sum of all min terms equal to 1. Okay, so find y equal to A, B, C, D if truth table is given below. Okay, this is one of the good question I think. So let's see. Four variable. Okay, so how can you do this? So this is the problem basically A bar B bar C. So this is does not represent your M naught. Okay, this does not represent M naught and this is does not represent your M3 because it's a four variable. So D is your LSB. So D is your LSB, then M naught plus M1, and here A B C, that is 1 into 1. So that is your represent MC M6 plus M7 ABC. So it represent M4 plus M15, and here D, that is A B bar C bar, B bar C bar, and D. So D multiply. So it's represent M9, and here uh, A A B bar B bar and C and D bar is here. So it is represent M10, and finally this is my ABC. Here I think ABC, this term ABC and 1. So it's represent, it can be D bar and D. So if it is D, then 14, M14, M15 plus. Oh, this term is already written here. Okay. So this is the term we got from previous. And this is another question y equal to, so something like this. And now if I go through the KMM, though, like now it is easy. And max term. So a logical OR operation including all variables where each variable can be itself or its complement. So output of minterm function is 0 and maxterm function represented by Bm, and 0 normal form and 1 complemented form. Okay, here we can see if my both 0 0 like A0 and B0, then it would be written as A or B. So this is my max term, and also 0 1. So 0 1, it is this a plus b bar. So just it's a complemented form, but the difference is here, previously in mean term we multiply it, and now it's or, and like previously we add operation, and here is or operation, and the previously where there is one, we just take the normal like a b something like that, but here we take the, for 0 we'll take the like normal form, and for 1 we take complemented form. So same as here, and same as concept before. So this is 9 m9. So expression for max term. So what would be the expression? So expression, so it is m9 basically. In variable to the power n max term, so there are also max term. Here is ab plus 1 and multiply. So how we do? So ab plus 1, so that is 1. A plus 0, so a plus b bar. So here is also 1, and here is also a bar plus b. So a b bar plus a plus b bar multiply like and into a bar plus b bar. So it's basically gives me the, here it is m1. M1 means 0, 0, and b bar means 1. So it is m1, and here a bar plus b bar. So basically it's a bar means 1, and b bar, so 1 1, it's m3. So m1 and m3. So we represent like this: y is equal to m 2 4 3 like this, or pi m. So it's a max term. If it is with summation like this, y equal to, then it is min term. And here is the concept of don't care. Don't care, that is x. So here is the whole concept: product of all max term equal to 0. Find y equal to f a b c d if truth table is given below, and y equal to a plus b plus c bar. So multiply a plus b bar into c, and like this way we can do the same thing. So previously we also did that. This does not mean that a plus b, so a means 0 0 and 1. Sorry, positive 0 0 1, so that is not m1, because your lsb is not c, so d is also there. So that is d depends on d, so if d bar, then it is 1 also. So then it's m3. If d not, then 0, so this is m2. Okay, so this is m2 and m3. Y equal to a b c d, so that's the way you can, like in POS form, in max term form it is given. So this is normal concept, just go through this. Sum of product and product of sum, SOP product term, or add together ABC, like something, SOP form, POS form, like something like this. Inner the summation, and outer the AND operation. Standard canonical SOP and POS form, present in product or sum term each. All the variables should be either in normal form or complemented. So example, f equal to abc is given as 1 A plus B multiply B plus C bar, not a standard POS. So it's not a standard POS form, product of sum form, and it is a standard POS. Okay. Not a standard recipe. So basically, for standard case, like you need a three. Like three variable means all three uh, inputs are present. So that's why it's a standard form. Otherwise, if the any of the input is missed in any SOP or POS form, like suppose here A is missing and here is C is missing. Maybe it's C bar C something like that, or A B. If you want to open it, so it's look like A plus B C bar and A plus B. So this is that standard form AB. So that's the like that's we want for standard form. So it's not a standard form. For the given function, write minterm and maxterm, then write standard SOP and POS form. Okay. So first write a minterm and maxterm. Write minterm and maxterm. Okay, A plus B plus C. So it's a SOP form, and now if you want to convert it POS form, POS form. So minterm. Just go through schema. It is easy. Like A 0 1 1 1 1 1. So and B bar C 0 0 0 1 1 1 1 1 0. So B bar C this. Okay. So mean term is 4. Mm, for B bar C this. So standard SOP it will be calculated 4 5 6 7 1 1 4 5 6 7. So this is standard and standard POS. So one is the function of standard for standard POS, like this term is not present, so this will be the standard your PS A plus B plus C like this. So basically you just write all the input term, like either C bar or C, B bar or B, or A bar or A. Standard POS A for A, B, C, A plus B plus C bar, standard POS 001 M1 max term, summation of M 0 2 3 4 5 6 min term, triple 0 0 1 0 0 1 1 0 0 1. So standard SOP this is, and standard SOP like this M2 M2. And what is the functions y equal to A plus B bar C in POS form? So basically M0 M2 M3. This is the I think answer of this. So yeah, this is 2 3 and a 0. So 2 3 0 2 3. So 0 to 3 answer here. Just open it and try to do like this. A equal to your like fourth term, but here the function y equal to in POS form. Okay, so here five term will be there. So according to your questions, they required a POS. So for POS, the three, like here you can see the I came up I draw. So these three is required: M0, M1, M2, M2, M3. And mean term through logic gates. So this is AB, this is like AB. Both are common in this situation. A is common and B is common. So A and B. Here the either A, either B, or both are also be same. So both are also have give you one. So that is A plus B. And here is A. This is A, and this is my, like, not should not be B bar. So should not be B. So A B bar plus here A bar B. This is nothing but A XOR B, and A plus B bar. So basically it's out of box, like this. This is my audible. So this is totally A bar. Sorry. So how you write this? How I write? So basically A total is A, and this is B, and this position is not required. So this is bar. So outer side. This is A plus B, and how it's right? So basically if I write, this is my AB plus, and how is this? So basically this is my mm, out of the box. So basically we need this also, A plus B whole bar. So that A plus B is whole bar. Then how it would be right? This is, we can write A bar into B bar. So this is nothing but X NOR gate. And it is NAND gate. So how it is NAND gate? Basically this is AB, this is my AB, and it's not, so everything. So this is my NAND gate. Find output Y if F1 and F2 are given. So F1 is M 234 and F2 is my max term M. So this is my max term and this is my min term. So F1 and F2, so find output Y. Okay, so here is Y. Okay, so F1 F2. So if I go through KMap, so for F1 the KMap is here, and here is this my F2, and this is my F1. So for F1 the go through min term. What is min term? 2. For 2 is here, 2, 3 and 4. And for F2, so this is max term. Max term is 1 2 5 7. So this is my 1, this is my 2, and this is my 5, and this is my 7. Rest are 1. Here 1 1. So if we put and, then what my min term output? So min term output, so what is matching? So 3 is matching everywhere, 3 and 4 is matching. So 3 and 4 is my output in terms of min term. And OR gate, for OR gate, so 0 0 0 0 3 2 0 3 2 and 4 and 6. 4 sorry 4 and 6, yes. 0 3 0 2 3 4 6 is meant for not. So if1 not, so if1 not is easy, that is 0 1 0 1 5 6 7 0 1 5 6 7. F1 F2 NOR gate. So F1 F2 NOR gate. So 0 2 3 4 6. So if I NOR it, so 1 5 7. This is, and F1 F2 my XOR gate. So F1 X2 is my XOR gate. So here 1 0. So that is 1. So 0 will come. 0 come. 0 is here. 0 come to 0. This is 1. Both are 0. So this is meaningless. And for 2 2 will be there, 2 4 not there, 3 not there, 0 here, 0 not there, and again the 6 will be there. And if 0 to 6 are there, so obviously for x nor gate it the complement, so 1 3 4 5 7 will be there. Hello, it start, then it's counting 41.4. So now it start recording again. Let's try. Okay, so find y. So find y f1 f2. So the same problem, but it's a little bit big. So and a person or a person f3 is also be something. And so this is not a big deal. So we can do easily this kind of problem. And k-map. So whatever the previous I do, that is all about k-map. And basically the k-map here he taught. And f equal to f of a comma b. So that is summation of a1 to fill the k-map cell. Okay, it's simple. It's also simple. Three variable k-map, three variable k-map, and four variable k-map. So all about here is k-map. Nothing but nothing either. Only k-map truth table. So here is one. So 0 0 position one, but it's MSB type of k-map. So here is 0. That is the behaves like a min term of min term, like min term. In min term we take 1, and in max term we take 0. Okay, so that's just the opposite thing. Rules to be followed in KMF for minimization. Okay, there are some rules, so you can do only square, not other than that. Cubing can be done in order of 1 to 3. So these are type of how to do like box to minimize the circuit. This is some normal problem like how to KMF output. Okay, this is the problem. You are given an n variable logical expression in K-map. You have done grouping of 2 to the power k cell. What will be the literal could be that particular group given n greater than k and k is whole number. So n equal to 3 n variable. So this is basically 3 variable K-map, and k is equal to 1. So three variable, two cell grouping, y equal to b c bar. So the literal is 2. 3 minus 1, that is n minus k. Okay. Group 2 to the power k and LC n minus k. Got it. KMF for if ABCD is given, draw KMF for A bar ABCD. So it's just like a complemented form. So here is 0, there is 1, here is here 1, that is 0, 1, 0. So nothing more than that. Just complement it and try to do the like fill the KMap. So map the given logical expression in KMap and find reduce logical expression if ABC, A bar B, A bar or BC. So this is some problems. This is simple problem you can easily do. Cell. So five variable KMap. A B C D E. So A B C D E. How to do five variable KMap? So basically B C D. So A for 0 here and A for 1 here. B C D. So adjust the cell. So 32 cells. So like to the bar if I do 6 like 64 6 variable then 64 cells, so it's not possible for like making a cell of to the power 64 like this. Here is my U A B C D E summation of M equal to 3 4 6 11 12 14 17 20 22 25 28 30. So SOP of minterm, sum of product of minterm, or basically SOP is basically minterm. Here we take the A equal to 0. So A equal to 0, then we do the BCD for BCD. So 3. So 3 how I represent? So it comes to A bar position. So A bar, then BCD. So DE is my 1 1. If my DC is 1 1 and BC, so this is my 3 basically. This is 3 and 3 4. 4 means this is my 4, I think. This is 4. Yes, this is my B bar C, D bar E. So this is 4. 6. 6 means this is my 6. So B bar C, D, E bar. This is 6, 11. So only up to I think 15. 15 would be there, and after that and then to 20 like this. So solar 16 plus 16. So this is the way we can do like solving our problem. Okay. Find A, B, C, D, E. So A bar, B bar, D plus B, C, D like this. So draw KMF. KMF of XOR gate and their complements. If equal to AB, A bar B, AB bar, XOR gate. Here A plus B. Okay. Here is again corner. So lots of problem regarding K-maps related to K-map. Here the answer also. Implicant, prime implicant, essential prime implicant. Okay, so now new concept, that is implicant, prime implicant, essential prime implicant, and redundant prime implicant, and also selective prime implicant. So first implicant to prime implicant, and prime implicant to, we decided that this is EPI, RPI, or SPI. Okay, so this is implicant. So basically G, here is the one function. So G1 is 1 9 12 15, that is implicant, and M is 0 6 12, that is also implicant, but 0 1 3 4, 0 1 3 4, this is not an implicant. Why it is not implicant? Because I think 3 is not present in here. Okay, 3 is not present, so for that why it's not implicant. If equal to ABCD, so 0 to 15 like this way, 0 1 5 7 10 11 14 15. So G1 ABCD, so ABCD plus AB bar CD, and ABCD bar A bar AB bar CD bar. So this is M 10 14 11 15, that is implicant. So prime implicant, a best possible group. So process of finding prime implicant. Okay, so here prime implicant is 5. So how it is 5? 1 1 is here, 1 is here, 2, this is 3, this is 4, and this is 5. So maximum number of, not maximum, like uh, minimum number of group that will cover all the implicant, so that is called prime implicant. Basically start with the best possible group, 8 cell, 4 cell, 2 cell, 1 cell. Inside the bigger cube, no further small cubes allowed. Okay, best possible group, what I told. And here is my 1 and 2. So there is, here is 2 prime implicant. Basically 2 prime implicant. So implicant is 1 2 3 4 5 6, but prime implicant is 2. And yes, this is prime implicant. And here what is this? This is, okay, one group here, two group here, but this also we can group, but this is not, I think. And here is one group, and here is one group. So my one quad plus 4 pairs, one quad, एक दो तीन, एक दो, so 4 5. So total implicant is prime implicant is 5. Okay, this is also a prime implicant. Here 1, here 1 2, here 1 3, here 1 4, and here 1 5. So maximum prime implicants, 2 variable, 2 pi. Okay, only 2 pi. Or number of variables, here pi. For 3 variables, that is 6 pi. And 4 variables, 13 pi. That is the maximum number of prime implicant. So this is 13 pi, and detect the prime implicant for the function. So quad 1 quad plus 5, so that is total 6. No essential prime implicant. So here EPI, the group which covers at least one min terms that can't be covered by other group or prime implicant. At least one min term that can't be covered other group or by prime implicant. Okay. So here this one and this one. So only two EPI will be there. Here only this EPI and this we can be so here also two EPI. And PI is also here 1 2, and here is PI prime implicant 3, and implicant is not presenting here. And here is here one EPI and here is one EPI, so only two EPI will be 2, that is 4 and 5. And one group is here, one group is here, 2 3 group is here, 4 number of group is here, so 4 PI. Here is PI, and so first EPI, so this will not cover. So this group 1 plus this 2 and this one 3, so total 3 EPI is here. 3 EPI is 4. How it would be 4? One group, two group, and three group. 5 7. How 13 can be EPI? M equal to 1 5, that's the 1 and that's the 5 number group. What can be EPI? 8 10 10 also be. Okay, okay, okay. 0 to 8 10, 0 to 8 10. Okay, so we can also count the group higher, 1, or like here it is not covered, and here it is covered, but it's part of group, so that we can say that also the mean term of that group also comes under API. So yeah, we represent API. So 9 PI. 9 PI, 1 2 3 4 5 6 7 8, sorry, 2 3 2 3 2 5 2 7 7 through 9 PI. Okay, PI means group. Okay, sorry, my fault. That is, and one API, one API is higher. One API this one, but this can be also group. So it is unnecessary to make. So this is API, one API, two API, like this and this. Here this and here two API. Now it is redundant prime implicant. So RPI prime implicant whose each of the mean term is a part of some essential prime implicant. So redundant prime implicant RPI prime implicant whose each of the mean term is a part of some essential prime implicant. So here this is my prime implicant, this is my, and this is, I think this is redundant implicant. So RPI is here one and two API, two essential prime implicant, and PI is one prime implicant, two prime implicant, and three PI. Okay. Now go in this example. So this example, here is my first check implicant, one box, two box, uh, three box, four box, and five box. So five PI and EPI, one, two, and three. Three box are like unique, or you can say that this minterm will not cover with uh, other group. So that's why this is three PI and uh, and redundant. Redundant is, I think, redundant is here. This is my one RPI. This is RPI or SPI. This is my RPI or SPI. So API, this is not my API. Okay. G5 PI, 2 SPI is present. So selective prime implicant. SPI M12 and 18. 12 and 8, sorry. 12 and 8. This is not API. This is SPI. And this in 12 13. 12 13. This is also SPI. Okay. So okay, this two is my SPI under, and here is my PI. Here is PI. So one group is here, one group is here, two, three group is here, and four group is here. So one, two, three, and four. Four is my PI. But how it is five? Let's check again. Okay, here again one group. Here again one group. So that is also comes under PI. Now check the EPI, essential prime implicant. So essential prime implicant here is, this term is not covered. Here one, and here one. So three API. Now check my any redundant prime implicant or not. So this term, I think my redundant prime implicant. This is not my. I can say that this is not my SPI. So two RPI, that is 4 5 6 7. This is also my RPI, I think. So 4 5 6 7. 4 5 6 7 6. So this is my another. Okay. Okay, understood. And this is my another RPI. 6 7 6 7 14 15. So two RPI is present. So before that, why it is SPI? Why is SPI and why it is RPI? So basically, the EPI is this for this bit covering we need, but for if we go through red pen, so this will be cover, this will cover these two bit. So and this also cover this, and this also cover this. So what's not cover, like it's actually extra, so this is redundant, it's not required, and this bit might not required. So this is my unessential. So this is actually basically my RPA. Maximum number of EPI, 2 variable, 2 EPI, 4 EPI, 4 variable, 8 EPI. Yeah, example with don't care X. So hello don't care will not frame any group. Use don't care in clubbing if it helps in increasing the group size. Okay, here if we increasing, then it unnecessary, but this is unnecessary. Okay, why would put extra gate for this? So this is unnecessary, but mm, we can take this. This is helpful, and if we want to take this is also helpful, but this and this is my bad. Okay, assignment 2, the minimize came up minimization like this. Minimization express complemented of fxy, this f of abc. Find the number of essential prime implicant EPI. So EPI, how we find, this is my 1 1. So EPI essential prime implicant. So this will not cover, this will not cover, this will not cover, this will not cover, and this will not cover. So there is 4 EPI, 4 PI. Some minimization or like something boolean expression equal to just like this. Now number system, that is number system are decimal, binary, octal and hexadecimal. Any number with base y, base r. So 0 2, that number minus 1, so 0 1 2 something like that, and r minus 1. So for my base is 8, so the max is 7, up to 7. My base is 10, so that max to 9 like this. And also hexadecimal number is present, and decimal number system. So for decimal number system, base 10, 0 1 2 3 4 5 6 7 8 9. 2143, 3 multiplied to 10 to the power 0 plus 4 into 10 to the power 1, something like that. We can get 2704. We get now this number is 2743, represent like this way. And for decimal, like after point, so after point it is look like this: 5 into 10 to the minus 1, so this is 0.53 into 10 to the minus 2, so this is 3, like this. Binary number system, so base 2, only 0 and 1 are present. So this is my half, this is my 1 by 8, so for 1 by 8, 2 to the power minus 0, 1, 2. So here is 1, 2, 3, minus 3, something like that. Octal number, in octal number also 8 to the power minus 1. So just remember here 8 to the power 0, so 0, 1, and this is the, like sometimes we do like 8 to the power 0, so this is not 8 to the power 0, this is 8 to the power minus 1. And hexadecimal number, in case of hexadecimal number, so base is 16, so 0 to it goes to F, so 9, after 9 this is A, so 953, that is base 16, so we can write this way: 3 into 16 to the power 0, 5 into 16 to the power 1, and 9 into 16 to the power 2, so that is 2387 base 10, that is in decimal form. Any base to decimal form like this, and decimal to any base. This. Understand the method by example. So integer part 73.25, 0.25 into 2, so 0.50, 0.50 into 2, that is 1.00, 0.00 into, so something like this. Conversion from any base to other base. So how to, so we can mediator is base 10, so we can use base 10 as a mediator, so we can convert this number into this other way. And how we can do, so 90, this number we converted into base 10, so 1 plus 4 into 5 plus 3 into 25, like 5 square plus 1 plus 5, so that's the way we got this number. If we got this number 96 by 6, so that is 16, 16, so 0, here is 2, so 4. So how we can write this? 0.286, so it's multiply. If we multiplied, then 1.68, 4.08, and with 0.8 multiply with 6, that is 0.48. So something like that. My answer is equal to 240, 240.1, 1 point, this 4 I will take 4, and this 0 will take, so almost base 16. So you just take the mediator. Mediator is my base 10. From base 10 we can calculate any number or convert any number. So special case binary to the power n number system, that is n. Here is some special case 2 to the power 3, 2 to the power 4, 2 to the power 2, 4. Okay, so how we can write directly? So to do a number system like this, so for base 2, this is like this, and this is so 7 4 2 3 2. So 7 4 2 and 2. So this is also my base 2. So if we write in a simple way, so this is my I can write. And for 16 7 EB2 A4 16. So to the 4, each number is 4 bits.